Hello guys, in this video I'm gonna talk about row echelon form and Gauss algorithm or Gauss elimination, which is used to solve systems of linear equations. We say that a matrix A is in row echelon form if the number of zeros at the beginning of each row is strictly increasing row by row. Let's look at the example. Which matrix is in row echelon form? Look at the first one. Here in the first row there is no zero. In the second row we have 2 zeros, and here 3 zeros and 4 zeros. So that the number of zeros is strictly increasing row by row. Because of this, A will be in row echelon form. Using the same method, B is also in row echelon form. But for C, the number of zeros in the first and second rows are the same. Because of this, it's not in row echelon form. Not row echelon form. That's all. Let A be n times p size matrix. Then the following algorithm, called Gauss algorithm or Gauss method, allows to transform A to its row echelon form. Suppose that the matrix of A is this one. A1 1, A1 2, A1 P, A2 1, A2 2, A2 P, AN1, AN2, ANP. In the first step, we should define the pivot. Let's write the definition of pivot. Pivot is the first non-zero element of a row. Pivot is the first non-zero element of a row. In step 1, our input will be this matrix. And you see here, we have if operator. First, we look at the first column. If all elements of first column are zeros, in this case, we move to step 3. Here. Our matrix will be this one. 0, A, 1, 2, A, 1, P, 0. All of the elements in the first column will be zeros. This is A2, 2, A2P, AN2, ANP. If it's not true, if the first column contains at least one non-zero element, in this case we assign A11 to pivot. If A11 is a pivot, in this case we move to step 2. If it's not, we check the other rows of this matrix. If the first element of ith row is non-zero element, then it will be pivot. In this case, we replace the first row and ith row and move to step 2. Then here our matrix will be this one. A1 1 prime, A1 2 prime, A1 P prime, A2 1 prime, A2 2 prime, A2P prime, AN1 prime, AN2 prime, ANP prime. As you know, this matrix is the row equivalent to A. In step 2, our input will be this matrix. We don't touch to the first row, and we use a pivot A11 prime to eliminate all terms A I1 prime, and here I is greater than 1. To do this, we use this elementary operation. Then at the end of second step, our matrix will be this one. A11 prime, A12 prime, A1P prime, here it will be 0, 0, all of the elements will be 0, A22 2 prime, A2P 2 prime, AN22 prime, ANP 2 prime. This is also row equivalent to A. In step 3, our input will be this one or this one. If the first element of the matrix is 0, if yes, then we take this submatrix. If it's not 0, we remove the first column and first row in input. Then our submatrix will be this one. We take this submatrix. A and P, and this one is this matrix. Two prime, A to N, sorry, P, 2 prime, A N 2 prime, A N P 2 prime. At the end of step 3, the result will be this matrix or this one. Depending on this condition, we take this matrix or this matrix instead of A. Then we take these matrices as an input in step 1 and repeat this procedure, so that at each iteration we apply the steps to the submatrix of A until obtaining a row echelon form. And our final result is this type of matrix: B11, B12, B1P, 0, B22, B2P, B, and P. It's row echelon form of A. That's all. Example. Transform the following matrices to their row echelon forms. You see we have two matrices A and B. And here I'm going to find the row echelon form of A. You can find the row echelon form of this by yourself. Okay. Our matrix is this. A is 1, 2, 3, 4, 0, 2, 4, 6, minus 1, 0, 1, 0. You know we apply the Gauss algorithm in order to define the row echelon form of this matrix. Let's start the first iteration. First iteration. Step 1. In this step, we take this matrix as an input and we define the pivot. Let's look at the first element. Pivot is 1. It's true. Because of this, we move to step 2. In this step, the matrix of A will be our input. And we must cancel the first elements of second row and third row. First element of second row is 0, therefore we look at the third row. To the third row, we apply this elementary operation. Instead of L3, we write L3 plus L1. Then our new matrix will be this one. 1, 2, 3, 4, 0, 2, 4, 6, 1, 2, 4, 4. We move to step 3. Our input will be this matrix. We assign the first element to the pivot. It's true. Then we remove the first row and first column and take this submatrix. This one. A prime is 2, 4, 6, 2, 4, 4. We start the second iteration. We return to step 1. We take this matrix and consider the first element. Pivot is equal to 2 is different from 0. Therefore, we move to step 2. In this step, we take this matrix, this is our input, and we cancel the first element of second row. In order to this, we use this elementary operation. Instead of L2, we write L2 minus L1. Then our new matrix will be this one. 2, 4, 6, 0, 0, minus 2. This is also a row equivalent to A prime. We move to step 3. In this step, we take this matrix as an input and consider the first element. First element is different from 0. Pivot is 2 is different from 0. It's true. But you see, this matrix is in row echelon form. Because of this, we stop here. From here, the row echelon form of A will be this matrix. Instead of A, we write this matrix because you know this matrix is row equivalent to A. And instead of this submatrix, we write this one. Then the result will be 1, 2, 3, 4, 0, 0, and instead of this one. 2, 4, 6, 0, 0, minus 2. That's all. Okay, see you guys next lesson.